Well, good morning, everyone. Welcome to this talk. Thank you for coming. Can we switch to the... No, it doesn't work? Oh. It should. Yeah, that's better. Thank you. All right, so welcome to this talk. Thank you for coming. This is a talk about lambda expression, free your lambdas. It's in fact a replay of a talk I already did last year. So if you saw this talk last year, it's mostly the same this year. This is a tutorial session, so we will be starting at the very beginning of lambda expressions. I will not assume that you have any knowledge about writing lambdas. Who never wrote lambda expressions in Java? All right, so that's, 10% of the audience. And who, if you consider yourself as a seasoned lambda expression writer, okay, about the same amount of people. So we'll build up on things from slide to slide, example to example, to create patterns that we can't write without lambda expression. This is really the topic of this talk. It is really about lambdas and functional interfaces and things like that. It is not a talk about streams and collectors, so I will not be covering this topic at all. I will to use lambdas in collections, streams, and collectors. By the way, there are available seats at the front, so please don't stand. I'm sorry. If you have an available seat next to you, can you raise your hand? Okay. Take your pick. All right, my name is José. I live in the Paris area. I put just some link here, my Twitter account, GitHub account. I have two open source projects called Streams Utils and Collectors Utils that you might check if you're interested in. And I also have a SlideShare account. I'll publish those slides on my SlideShare account by tonight, and also some content on GitHub. By the way, I'm also a Java champion and a Java rock star, even if I can't play any kind of music. This is how it goes. Before we start, I'd like to apologize because for the next 2 hours you'll have to learn English spoken with a French accent. Sorry about that. The alternative would be that I speak French, but it probably wouldn't work much. Okay, so if you have questions, 2 solutions. You raise your hand, you shout, you make yourself heard so that I can hear you and see you. If you don't, or if you have questions after the talk, whatever, you can use this hashtag, and I'll try to watch it, to monitor it, so that I can answer you using Twitter. Okay, we're going to begin with very basic stuff. The first question, what is this code doing? This is the easy quiz of the day. Right, so this is basically a comparator, okay? Comparator, this is Java 5 code, right? We could write this code in 2004 when Java 5 was released. And this is a comparator that basically compares 2 people using their last name. If I want to sort a list of people, I can use this comparator. This is very basic stuff. 2 questions. Do you think this code is readable? No? Oh, come on. It's not that bad, right? I wouldn't say it's very readable, but it's kind of okay. We're used to this code, in fact. Would you say that this code is robust? Can it crash? Yes, it can crash. Right? If P1 is null or the last name is null, I do not check for any kind of null pointer exception, so null pointer exception can be raised using this kind of code. All right. Let us make it a little more complex with this one. What does this code do? Well, basically, it kind of does the same thing. Compares 2 people using their last name, and if the last name is the same, it compares the first name to sort this list of people. And if I ask myself, is this code readable? Is it more readable than the previous one? Quite not. It's probably less readable. Why? Because I have an if in it. And I guess we all know the Sonar toolkit. there is this cyclomatic complexity computed by Sonar, and we have increased the cyclomatic complexity of this code. So yes, readability has decreased a bit. And also robustness, because if P1 is null, get last name returns a null value, or first name returns a null value, this code will also throw a null pointer exception, which is not that nice. If I want to make it robust, it will be much more complex and much less readable, because I will have all this technical code to check for null stuff inside my application code. All right. What is this code doing? Compare people using their last name, then using their first name, and if the last name and the first name is the same, which can happen, of course, compare using the ages. Yeah. How about readability? Not that great, right? Much lower. I would say that this is the kind of code we're so used to see in applications that we do not really need to read it line by line. We just have a global look at it, and we understand what it does, and so we understand what it does. Yeah, in a nutshell. And it's not that robust neither. And by the way, since we do not read it line by line, we do not see problems that could have sneaked in those code. Yeah, right. Some of you have seen that. If you check, really, I will fix the code, right? Oh my God. I was comparing the last name of the first person with the first name of the second one. Did you see? Let me show it again, right? Since we have some kind of automatic reading of this code, we do not, we give places for sneaky bugs to hide it. And indeed, there was a bug in this code that maybe some of you didn't see at first. You better have a very good unit test case to fix this code, all right? To see this bug, because you need to have two people with the same last name, and the last name of the first person has to be lower than the first name of the second person to see this kind of code. So this is typically the kind of bug that will make it into your production code. If you're just sorting lists of students or pupils in classroom, it might be okay. But if you are drawing the winner of a 1 million prize in some kind of lottery, you might be in trouble if you do that. Okay, so the problem with this comparator, here I am really trying to address a very simple and very classical problem. I need to sort a list of people using their last name, their first name, and their age. And every time I add a criteria in this comparison, I increase the cyclomatic complexity, I decrease the robustness, and I have a terrible mess of a code that is very hard to fix if there are bugs in it. So this is exactly what I do not want to do, and this is what we're going to address using lambda expressions and patterns with using default methods and stuff. Basically, the code we are going to write is this one, which does the exact same thing as the previous one. The difference being, if I add criteria to my comparator, I will just add method calls, so I do not increase cyclomatic complexity. And all the code that is going to make my comparator robust, that is all the code that will check for null pointer exception and stuff, is pushed in the API code, does not leak in my application code, so it does not make my application code any more complex. All right. So let us take a closer look at the comparator. Basically, what we want to do is to sort a list of strings of character, so that we can create a comparator of string. Here I'm sorting my strings using their length instead of the alphabetical order, for instance, the natural order. Okay, so I can create a comparator. This is the Java 5 up to Java 7 way of writing it. And what do I do with this comparator? In a nutshell, what I want to do is to pass this comparator to sort methods. So I've got two in the JDK, arrays.sort and collections.sort. And those sort methods are going to use this comparator later on. What did we do? We just passed a piece of code as a parameter to a method. And this method, here in this case the sort method, will be using that code later on, and several times. All right? And why did I use an instance of an anonymous class to do that? Well, just because this is the only way I have to pass code as a parameter in Java 7. If I want to pass code as a parameter in Java 7, I have to use an instance of an animals class. I do not have any other solutions to do that. With lambdas, I can pass this code precisely as a lambda expression. So lambda is basically a way to rewrite this comparator. How is the lambda written? I just need to consider that I have a block of parameter to the method of this comparator. Here, the two strings, and a return statement. And the lambda is built as that. I just copy-paste the block of parameter, draw this little ASCII art arrow using a dash sign and a greater than sign. This is nostalgia about the old days of computing, right? And push the return statement as is. This is the way, and we're going to see many examples of that. This is how we write lambdas in Java 8. The comparator interface becomes, in Java 8, what is called a functional interface. What is a functional interface? It's an interface that has only one abstract method. This is the most simple definition of what a functional interface is. A functional interface may be annotated with this functional interface annotation. It's not mandatory, it's optional. You don't have to do it. If you do it, the compiler will tell you at compile time, that is in your IDE, and we'll see that, if this annotated interface is indeed functional or not. If you don't do it, then the compiler will tell you, if you try to implement this interface using a lambda, hey, you can't do that because this is not a functional interface. So it's just something that is here to help you, to help us. It's not something that is mandatory. By the way, since it is not mandatory, it is also a way to take your old Java, let us say 5 code in jars, and implement it using lambda expression in the Java 8 parts of your application without having to recompile those old jars. So it's also there for backward compatibility reasons. Demo time, great. I love demos, but I need my glasses. Okay, is the font big enough? Yeah? If you can't read the code, just tell me I can. Yeah, okay. Let me do that. While I'm doing that, if you can raise your hand if you have an empty seat near you, because there are people standing up at the back. Is it better? Yeah? Is it enough? Okay, fine. So this is a list. Okay. Well, it's a list. There's nothing much to say about it. And we are going to use this. Oh, please. Yeah. This new for each method defined on the Iterable interface that takes a lambda that is going to be applied on the list. And here, this for each method takes a lambda expression as a parameter. And the question I'm asking myself is, how can I write this lambda expression? To write a lambda expression, you need to identify what is the interface you need to implement. It has to be a functional interface. And what is the abstract method of this interface? So this is what I'm going to do. For that, I can navigate to the for each method. Okay, it's a default method. I'm going to see that in a minute. This method takes a consumer as a parameter. So I'm going to watch this consumer interface. This is indeed a functional interface. So by definition, it has only one abstract method, which is the accept method here. How can I implement this abstract method using a lambda? Well, as we saw in the slides, I just need to copy-paste the block of parameter. Let me do that. Draw this little old-fashioned arrow-like ASCII art, and return void. So if I just want to return void, I can write it like that. This is a block of code that returns void, so at least it should compile, as long as I say that this T is in fact a string. And indeed, this code does compile. The lambda I just wrote using this method is an implementation of the consumer interface. Of course, it doesn't do much, so let us try to be smart here. I'm going to print out this string of character, okay, that I call T and not S. And if I run this code, okay, it just print out the content of the list frame. By the way, I do not have to write the type of the parameter here, because the compiler is smart enough, since he knows the method I am implementing, it is smart enough to guess the type of T. So the compiler knows that this T is in fact a string of character. So you see that it's not that complex to write lambdas. Let us take another example with another functional interface, which is the iterable interface. Let us write an iterable of string. Okay. Let us take a look at this iterable interface. This iterable interface is not annotated with functional interface, but it has only one abstract method, which returns an iterator, does not take any parameter. Let us implement that method using a lambda expression. Copy-paste the block of code. It's an empty block of code. Draw this little arrow stuff, and return an iterator, so I could well return the null value. This code should compile, and indeed, it does compile. Now, I should be returning, of course, a real iterator. I've got a list of strings here, so I can just take the iterator from this list of strings, and this is an implementation of the iterable interface. I can check that just by passing this iterable to this for each pattern and print the result like that. It indeed prints out all the elements of the interface, of the list. We can take one last example with another interface, the executor interface. Executor. This executor interface is also a functional interface. It has only one abstract method. Once again, it's not annotated with functional interface, but we can still work with it. It takes a runnable as a parameter, so let us take this block of code and copy-paste it. Draw this little arrow, and it returns void, so I can implement it using this DOM code, and this should compile, and indeed it does. Now what I need to do is, of course, execute this runnable, so I could write this command.run, for instance, to execute this runnable. I'm going to call this executor dumb executor, because of course it's executing the runnable in the current thread, which is not what an executor should do. If I want to create another executor that I can call smart executor and run this task in another thread, I could use this executors, I think I have it, yeah, executors factory method, new single thread executor, execute, and pass this command as a parameter. Let me put this like that so that we can see it. All right. We can test this code. For that, I need a runnable. This will be my task. By the way, if I check the runnable interface, guess what? It is also a functional interface, so I can implement a runnable using a lambda. Let us do that. What does it take? It takes no parameter and doesn't return anything. So I should be able to implement it like that. Ah! Looks like JavaScript, right? Okay, so this is a runnable. It compiles, all right? And it would work. Of course, it wouldn't do much, but it would work. So what I can do is, for instance, just print out the thread I am in thread thread.current thread, get name, something like that, and then dump executor execute this task, and do it again with my smart executor. If I run this code, indeed, the first one was executed in the main thread, which is exactly what is expected, and the second one executed in pool one thread one, which is the thread of my executor service. I need to shut this by hand because I did not shut down this smart executor, which is of course very wrong. Don't use this kind of code in production. Just one note, if I take this code here as an iterable and copy paste there, I have, I don't know if you can see it, I have a compiler, error. This code does not compile. Why? Because the compiler has to know at compile time the type of the lambda expression I am writing. So lambda should be either affected to a field or variable, or be sent as a parameter, or be returned by a method. I cannot take a lambda as it is, put it just like that in this code, and hope that it would work. For instance, if I just copy-paste this code here like that, put it into parentheses and call it like that, I will have a compiler error because the compiler cannot guess what is the type of the lambda I've just written. I need to put it in a variable for that. I'm going to switch to this code. All right. All right. Let's continue. So, writing a lambda in a nutshell is a matter of finding what interface, what functional interface I am implementing, and in that interface to identify which method I am implementing. And when I have identified that, it's a matter of taking the block of parameter, understanding what should be returned, and be smart and put the right code in the body of the method. So basically a method, lambda, is just a method that I can pass as a parameter in my code, in my application. There's something kind of weird that just happened. Yes, this funny syntax is called a method reference. We're going to see that in a minute. That is, the for each method is defined on the iterable interface. This is the code that we just wrote here, right? And has been added in Java 8. So adding a method in an interface, of course, implies that all the implementations of that interface should be updated for the code to work. And of course, it would have meant to refactor all the collection API and all the existing implementations of Iterable. Iterable is the root interface of all the collection hierarchy. So it would have required to update all the code around, which would not have been possible, of course. It would have broken the backward compatibility of the collection framework, which is not possible. It's a no-go in Java to do this kind of thing. So the way interfaces work, if you have an empty seat near you, can you raise your hand again? Please come and have a seat, don't stay at the back. So the way interfaces work have been modified in Java 8, and the for each method is in fact a default method. What is a default method? It's a regular method added in an interface along with its implementation. It just had the default keyword in front of it, right? And does something. It is just a plain regular method, very easy to understand. This default method is a normal method put in an interface. What is new is that we can now have implementations in an interface. It was not possible up to Java 7. But it is a new concept of interface. It is not a new concept of method. It is just a plain old regular method as we're used to write them. This is how it has been sold to us when Java 8 was released almost 4 years ago. But it is much more than that, and I guess that in a few years from now, people will not be learning that default method have been introduced for the backward compatibility, blah, blah, blah. They will learn something else. And by the way, we can also put public static methods in Java 8. in interfaces, which is new. And in Java 9, we'll be able to put private static methods too. So a functional is so now in an interface, I can have abstract methods, default methods, and static methods. Only abstract methods count to tell if an interface is a functional interface or not. Default and static method do not count, which is nice because it means that I will be able to put abstract methods in functional interface and add a bunch of default method, which is what I'm going to do. Another demo. I love it. What are we going to do? I'm going to close this stuff. I don't need it anymore. I've prepared two interfaces we're going to use now. First, the My Consumer interface, which is a mimic of a consumer interface from the Java util package that we're going to talk about in a minute. And we're going to do stuff with it. What is a consumer? It has only one method. This is the system.out.println we've been using with the for each method a few minutes ago, right? So I'm going to create a first consumer string. For instance, eating, yeah. System out println, what are you doing? System, come on. All right, it doesn't work. Yeah, this is the one. Eating S, okay. And if I'm calling the accept method of this my consumer interface, eating chicken, and I run this code, it just displays eating chicken, which is nice. And I'm going to write a second consumer, drinking. It does almost the same. Drinking, and I'm going to run it. Drinking, accept, coffee. Okay, eating chicken and drinking coffee. Now suppose I want to create another consumer, eating and drinking. I want, in fact, to compose those two consumers into one, just one. And for that, I would like to write this kind of code, and then drinking. Okay? Of course, this and then method doesn't work. I need to create it. How can I implement this kind of thing? This is very basic pattern, right? I want just to create a consumer that will be the combination of the first consumer and then the chaining of the first consumer and then the second consumer. If I check this method, and then, what is this method? It is a method called on the eating object here. So it's an instance method of the eating object. So I have on this my consumer interface another method called and then. Of course, that is going to take something and return something. What does it take as a parameter? It takes a my consumer. And what does it return? It returns another my consumer. Let us do that. I take a my consumer as a parameter and return the my consumer object. If I write it like that, this interface is perfectly legal, but of course, here I've got problems because I have an interface that has two abstract methods. It's not a functional interface anymore, so it does not compile. I cannot implement this interface using a lambda. By the way, if I add, this functional interface annotation here, you see that this time the compile error will be raised on the interface itself since I have two abstract methods and this interface is not a functional interface anymore. So adding this method as an abstract method is not the way to go. But remember, I can add default methods on my functional interface, on any kind of interface, by the way. So let us make this interface default. This time I need to provide an implementation. For the moment, let us just return null. And you see that this code does compile. My interface is functional again. And of course, I can implement it using lambda expressions. So now what should I do in this and then method? What I need to return is a myConsumer. Okay? MyConsumer is a functional interface, so it can be implemented using a lambda. What is this lambda? Well, you just need to apply the exact same method we applied previously, identify the only abstract method of the myConsumer interface, then copy-paste the block of parameter, draw this little funny arrow-like stuff, and return, okay, void. So if I write it like that, it should compile. And indeed, it does compile. This is a consumer. All right, so now I need to be a little smarter. What I expect here is to first consume the object I'm going to pass to this composed consumer, to consume them with the first consumer, the consumer I am in, this consumer, and then the consumer passed as a parameter. So let us do that. When I am in this code, I am in an instance of a consumer, so I can call this .accept of t, maybe print out something like that, and then consume this t object with the other consumer passed as a parameter. All right. Now, if I eating and drinking, except good food. Okay, I'm not really drinking good food, but anyway, it will just work like that. My default method implemented, in fact, the chaining of the two consumers, this and other, passed as a parameter. So you see that using this kind of default method it allows us to, in fact, opens up a whole way of new patterns that is composing lambda expressions, and this is what we're going to do until the end of this session. Let us take another example with another functional interface from the JDK that I have mimicked here. Any available seats in the audience, please? Yes. Come on, don't stay stand up at the back. All right, so my predicate interface. Once again, it is a mimic of the predicate interface available in the JDK. And we are going to write some stuff with it. So we are going to take, for instance, my predicate of string. Yeah. My predicate of string, not null, right? And it will just check if this given string of character is null or not. And I'm going to take another one, shorter than 10. All right, S, it will be s.length, length lesser than 10. Those are two predicates, and a natural way to combine predicates, to compose predicates, is, for instance, to use an AND method, so not null dot AND shorter than 10 should also be a predicate of string. Me, that I'm going to call, let's say, P1. Okay? So once again, I am facing the exact same problem as the composition of my two consumers. Here I have an AND method that is an instance method of the not null object. So it is an instant method in the myPredicate interface. It cannot be another abstract method, because if it was, it would break the functional interface stuff. So I'm going to make it a default method. And then this and then method takes a predicate as a parameter and returns also a predicate. Let us do that. So returns a predicate, takes a predicate as a parameter. So if I just return null here, it should at least compile. It does not. Oh yes, sorry. This is just an and here. So now it should compile. Thank you. All right. So what do I return? My predicate. How do I implement a predicate using a lambda? This lambda is an implementation of the test method that is here. Always the same process of creating this lambda. So I'm just going to copy-paste the block of parameter. I need to return a Boolean. So if I just return true, it's the first step to see at least that code compiles. Indeed, it does. And this Boolean should be the logical AND of the predicate I am in, using this test method, and the predicate passed as a parameter. So here is just this test of t and other test of t. We can test this code. p1.test here. System out println test with null. Run this code. Oops. Oh yeah, you're right. Sorry? Line 9. Yes, well, this is a predicate. I'm lost, guys. Oh, yeah, you're right. Sorry. Yes, that's right. Fine. Oh, yeah, on here I need to pass null. Okay, thank you. What happens? Okay, so this works like that. What happens if I pass null as a parameter here? This is interesting. If I run this code, of course, oops, it does work. So I'm going to call it with this code. If I run this code, of course, I have a null pointer exception. But the interesting point is, where does this null pointer exception come from? You see that it comes from inside the lambda, which is here. If other is null, this code is going to throw the null pointer exception as long as the first test is true. So it means that if I do not call this code is going to run perfectly well. You see? So if I create a predicate with an other that is null, I have a corrupted lambda expression that is bound to throw a null pointer exception somewhere, but this null pointer exception will not be thrown at the creation of the lambda, but when I will be using this lambda in my application. So if I pass this lambda to some kind of other module in my application, and this lambda is used in 10 days from now, this null pointer exception is going to be thrown much later than the moment where this lambda is created. And this will make a kind of impossible to fix bug, because the stack trace I will have will give me the place where the lambda is used, when the bug is in fact at the place where the lambda is created. So if I want to prevent this kind of stuff, I need to throw the null pointer exception at the lambda creation that is here. Now if I run this code again, of course the null pointer exception is thrown when I try to build the lambda. And this is a pattern we really need to use because we do not want to have impossible to fix bugs in our applications. This is an application of a very old principle in exception handling, which is fail fast, fail first. If I know that this lambda is going to be corrupted, I throw my null pointer exception right now. By the way, this is what I should have been doing here also. Objects require null other. Yeah? 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 You mean if I call and then, it will continue to work? No problem. And then? Yeah? Absolutely. You can chain consumers, you can chain as many consumers as you need, and you can compose as many predicates as you need with and create an OR methods, all this kind of thing. Yeah? What do you mean? In the code here? Yes, but this is what I've written. If this is what I need, it's okay. You see? This is a consumer. But there's nothing you can do to prevent that from within the and then method, because you don't know. Okay? This is a consumer. I could put that in a variable. And this is just a regular consumer, so I'm just calling and then method on the regular consumer. So there is no way within the and then method for me to know that in fact the consumer I mean is itself a composition of other consumers. I can't know that. Yeah. We can also predicate, for instance, we can also create other default methods. For instance, the P1, the shorter than 10. I could say, all right, I want to implement the negate operator on the consumer. This negate operator is also a default method, but this time it does not take any parameter. Okay, so let us write it, default. It returns a my predicate of t, called negate, and does not take any parameter. This is how I wrote it here. Sorry. Okay. So what should I return? Once again, this is a predicate. So I copy paste the block of parameters here, a little arrow, and this should return the negation of the testing of t, which I can write just like this with a not in front of it. So you see that default method allows us to implement composition and manipulations of functions as lambda expressions. Okay. So we've got functional interfaces to write lambda expressions. We have default methods to compose them. We also have static method that can be used as factories, and we're going to see that on further examples. What the idea is to give to our code better readability, essentially because we are moving some part of the technical code, especially the null pointer handling, to the API instead of having that code inside our application code. So this is what leads to better readability and also better robustness, because we can check for all the exceptions inside our code. And it also gives better performances. I will not be covering that point, but if you're interested in that, there is a very interesting talk by Brian Gates called Lambda, a peek under the hood, available on YouTube. We have, I mentioned several times, the my consumer and my predicate, which are in fact mimics of the consumer and predicate functional interfaces available in the JDK. In fact, I've got 4 big categories of functional interfaces in this Java util function package: the consumer, the supplier, the function, and the predicate. We will see examples of suppliers and functions in further examples. Those are the most basic implementations of those functional interfaces. The consumer takes something, does not return anything. The supplier does not take anything and returns something. The function takes an object of a given type and returns an object of another type. And the predicate is a special kind of function that returns a Boolean. I can also, well, those are more elaborate example of that. And I also have a 5th lambda expression, or a functional interface, that fits nicely I think, in this set, which is the runnable interface. A runnable interface is not new. It has been here from very early days of the GDK, and it's something that doesn't take anything and does not return anything. Think about a logger, for instance. Basically, a logger can be modeled as a runnable. Let us go back to our comparator example. We are going to write a comparator of people, and for that we are going to use a lambda expression, and then, an anonymous class, and then a lambda expression. It's demo time again. I love demos. Okay, we're going to close all this stuff. All right. Play with comparators. So I've got a my comparator interface, which is a mimic of the real comparator interface. All right. I'm going to play with it, and I also have a person class, which is a basic bean with 3 properties: first name, last name, and age. I'm going to play with that. So let us create a my comparator of person. I'm going to call it CMP1. New my comparator. Yes, if I do not import this person, we are going to implement it real quick, right? Person P1 and person P2. And what I want to do is the following. I want to P1 take the last name. This is last name 1. Where's my cursor? Here. And P2.get last name. This is last name 2. And then I would just want to return the comparison of last name 1 with last name 2. This is my comparison. Now, if I take a closer look at this code, what I can do here is extract that to a method. Right? And if I do that, I can see that, in fact, my comparator here only depends on this method. That is, if I want to compare people using their first name, all I need to do is change its code, and the rest of the code is the same. So the comparator I've written, in fact, depends on the method. Now this is nice, because I know that with lambdas, I can pass methods as parameters. So what I need to do is to transform this method in a lambda, and then I will be able to create a comparator just by passing this lambda as a parameter to some kind of factory method, for instance. Okay? What does this method do? It takes a person and returns a string of characters. Takes an object and returns an object from another type. The model for that, the functional interface, which is the model for that, is the function that takes an object precisely and returns another object of another type. So let us write this function. Takes a person, returns a string. I'm going to call it, I don't know, last name. Okay, takes a person P. If I have trouble implementing that, I can just navigate to this and copy paste whatever I need from this apply method here. I'm going to do it directly. Takes a person P. And call get last name on it. Now that I have this function, to transform this P1 into last name 1, what I need to do is call last name and apply it to P1. And do the same here. Last name, apply person P2 here. Now I do not need this method anymore. And now my code only depends on a kind of object. It's not really an object, but let us call it like that, which is this one. And I see that, in fact, all this code, if I put it in a method, yes, I can convert it. If I put it in a method, only depends on this last name here. By the way, I'm going to make it a lambda expression. All the IDEs can do that. Did not do it. It's extracted this, and this is, let us make it a lambda expression. Can convert that to a lambda. Okay? I have extracted this code into a static method, which is a factory method, that takes a function, and that returns the comparator, written as a lambda expression. So this method called extracted, since it is a factory method, and since I am allowed to put static method on interfaces, I can put it here, extracted. This method returns a my comparator of t. Since it is static, I need to declare the type here. And I am going to call it, for instance, comparing. What's wrong with it? Yeah, sorry. This should be a T. Okay. So now, my comparator is created by calling this factory method, my comparator, comparing last name. I do not need this static method here because I've moved it to the my comparator interface. And this last name is just this lambda expression, so I'm going to inline this and remove this code here. And by the way, this lambda expression can be written as a method reference. My IDE can help me in doing that. Person, colon, get last name. It's just another syntax. A method reference is just another syntax to write lambda expressions. And this is the final pattern to create comparators using those factory methods and lambda expressions. If I check the code, in fact, all the creation of the comparator itself using a lambda is now in my API instead of being in my application code. If I want to make this code robust, by checking if last name is null, the first thing I should be doing, of course, is throw a null pointer exception if last name is null here. By the way, I'm going to call that key extractor. All right. And if I want to check that last name, this is S1, and this is S2. It's not necessarily the last name. If I want to check if S1 or S2 is null, I can do it inside my API without having to lower the readability of my application code. But what I would like to do now is go one step further and say, all right, if the last name of my two people are the same, then I want to compare using their first name, for instance. Then compare person yet first name. What is the status of this new method, then compare? Well, obviously, it is called on a comparator. This is a comparator. Okay? So it is an instance method of the my comparator interface. I fall back on the same kind of question as previously. That is, that we saw with my consumer or my predicate. So what I can do is create this then compare method as a default method of the my comparator interface. It is going to take the same kind of parameter as the factory method comparing and returns also a my comparator of t. So let us do that. Default. As I said, it returns a my comparator of t. It is called then compare and takes a function that takes a t and returns a string. Now what I need to return is a comparator. The comparator is a functional interface an implementation of this method. So once again, I'm doing the same thing. Copy-paste this block of parameter. Then return an integer, for instance 1. At least it should work. And it does. Now I need to be a little smarter than that, of course. What should I be doing? First, I need to compare the people using the comparator I am in. So get the result of this, compare T1 and T2. Now, if CMP is equal to 0, then I need to fall back on the comparator constructed using the past key extractor. And if it's not the case, I just return the value of CMP. This code is gone. Here I need to create another comparator using the past key extractor there, but I've got this factory method for that. Key extractor. This is my comparator of T. I can call it other. And just return the result of the comparison using other. Okay? So this is an implementation, a possible implementation of the combination of two comparators created on two different key extractors. By the way, I also need to protect myself against the psychopath that could try to call me with a null key extractor. This one could even be written with a ternary operator. I kind of like the ternary operator. It reminds me of my old days of C programmer. Comparing key extractor. So if CMP is equal to 0, what I return is the comparing key extractor, which is the comparator, and compare T1 and T2. And if it's not the case, just CMP. And this code is gone. Almost. What's wrong with you? Sorry. Okay. Right, this is nice. So you see that we're almost done with our program. Do you remember this large piece of unreadable, crappy Java 7, blah, blah, blah code I showed you at the beginning? Well, we're almost there. We're almost there. We're not quite there because what I would like to do is compare it also using person get age. And this one does not compile. Why? Because age is an integer, and I wrote my code to take function that takes a string, that returns a string as a parameter. So I need to deep dive into more generic hell, which is something that everybody loves, of course. So I'm going to use a trick for that, right? See how can I do it. I put a string here. It does not compile. Yeah. Sorry. No, this one. String here, and I'm going to call it U. Hey, let's read it down. Never tell anyone you saw me doing that. All right, and I'll do the same here and call it U. So now what I'm basically trying to do is, okay, this is not a string, this is any kind of object of type U. So it will work now because this code does compile, but the static, the factory method does not compile because on this U object, I need this compare to method on it. And this compare to method, in fact, is defined on the comparable interface. So U has to extend comparable, and if you want to make it correctly, it's comparable of super U for some kind of odd reason. Welcome to the generics paradise. Okay, so if I do it like that now it will work, and the code will compile because integer is a comparable object as string is, and now my comparator can be written in that way. I could go even one step further, like this. by telling, okay, now that I have this comparator, in fact, I want to sort my students in the other way around just by calling the reversed on this comparator. So reverse, once again, I think you've got the trick now. It's also a default method of the myComparator interface. So let us write it. And you see that it's going to be very easy. In fact, default takes a myComparator of t, returns a myComparator of t. This is the reversed method. It does not take any parameter. What is returned is a comparator. So once again, implemented using a lambda. And it returns the opposite of the result of the comparison of T1 and T2. This compare T1 and T2. I have two tricks to achieve that. Either I put a minus here, and it will reverse the comparison. Or if I do not want to put a minus here, I can just compare T2 and T1 to achieve the same result. It's really up to you. Don't do both, because if you do both, it will not work, of course. Obviously. But you can choose either. I'm pretty sure that some of you are thinking, yes, I think that if I put the minus, it will be faster than if I compare. Okay, I don't know. It's really up to you. Yeah. I could also create other factory methods on this comparator stuff, for instance. My comparator of string, CMP2, and I want to create my comparator equals to 0, or compare to 0, for instance. To 0. This is a static method. Can I create it? Yes, I can. What did you see? Okay. Model, and I'm going to return the comparator, string S1, string S2, and return the comparison of S1 with model, for instance. Return, sorry. No, sorry, it doesn't make sense. I'm messing up with other stuff. I'm not going to do this one. Let us suppose, yeah, this is a string. So let us suppose that we just want to compare those strings using the natural order. I'm going to change, sorry for the confusion, I'm going to change the example. Okay? Because a string is already a comparable object, so I can just use the natural order of that. And this is going to be something like that, S1 dot compare to S2. You see? And by the way, I can do it for any kind of object that is comparable. U extends comparable. Super U. Yeah? Where did I what? Where? U has to extend, sorry. U has to extend comparable. Because what I'm doing is using this compare to method, which is precisely defined on the comparable interface. String implements comparable. It was the same problem as the previous one here. When I went from the string to U, if I do not say that U extends comparable, then U falls back to object, and I do not have this compare to method on object. This is why I can't use the compare to method. Here, I'm saying that U extends comparable, and this comparable method, which is, by the way, functional interface, has the compare to method. Right? So it's another way of creating factory methods on the comparator interface. Yeah, we can take a very quick look on the comparator interface from the GTK 8. It has the compare to method as usual, and after that, 500 lines, more than 500 lines of default and static method to create comparators using factory methods and combination of them. Right. Okay, so we saw how to use default method to combine and to compose predicates and comparator. We saw how to use factory method to create instances of lambda expressions without having any kind of complex stuff leaking in our code. Let us go one step further. By the way, I've been using method references in my code. I could show you other examples of that, by the way. Let me do that real quick, because we wrote lambdas that were in fact method references. This is a method reference. I have this magic shortcut in Eclipse, Control-1, and if a lambda is a method reference, you select it, Control-1, and it will give you the possibility to directly make it a method reference. This is also a method reference. And guess what? This one is too. Oh, and this one is too a method reference. Much easier, right? The next one is not. Okay, so there are 4 types of method reference. I've put them in this table: static, bound instance, unbound instance, and constructor. We'll see constructor in a minute. And I also gave you examples of how to pass from a lambda to a method reference in all the 4 cases. The slides will be available on SlideShare, don't worry, if you want to have that. I guess you all know this book. This is called The Gang of 4. It has a bunch of wonderful patterns in it. We're not going to talk about all those patterns, but what I would like to show you is just a hint on how to implement some of those patterns using lambda expressions, default methods, and factory methods in very efficient way. Let us begin with the factory pattern. Factory pattern. I love this one. The factory pattern. Let's close this. So I've created a class that is a factory. It doesn't do much for the moment. Is it the one I want to use? Yeah, no. This is the one I want to use. I'm going to use this prepared class. So what is a factory? Well, how do I want to create a factory? I have several other objects in my model package here. A shape object, which is just an abstract shape. There's nothing in it. A circle class that extends shape with 2 constructors that takes one that is empty and another one that takes a color. And also a square and a triangle class that we're going to use in the examples. How should I be using a factory object? This is my factory. If I want to create a factory of circle factory, basically what I expect from this factory of circle, I don't know how to create it, but what I expect is from this factory to be able to call a method, suppose a get method, that is going to return a circle. Right. This is the basic pattern of how to use a factory. Now, if I take a look at this code, if I take a look at this code from the lambda perspective, this get method here doesn't take any parameter and does return an object. So if you remember the 4 categories of lambda expression I have, this is a supplier, doesn't take anything, creates an object. So it means that my factory here is in fact not necessarily a class, could be an interface that extends supplier of T. And supplier of T is very nice because it has a get method that does not take anything and that creates something. So if I want to create an implementation of that factory, it's always the same. I just take a block of parameters. And what should I return? Well, a new circle. So basically, this is a factory from the Gulf implemented using lambdas in Java 8. And by the way, this is also a constructor method reference that I can write in this way. What could I do with this factory? Well, I could, for instance, say, okay, circle factory, give me 5 circles in a list. 5 circles. Java AWT list. Quite nice. What is this get method? It's not the same as the get method that does not take any argument. It's a method defined on the instance of the factory. So once again, this is a default method. Okay, so I can create here a default method. It returns a list of t, get, takes an integer. Let us make it return new array list, just to have it compile. This is a list and this is a new array list, and that's it. Okay. At least it compiles. Now what should I be doing in this? Create 5 circles and put them in a list. I could create a for loop, but I am using Java 8, so I've got this nice int stream object, then can create a stream of n integers for me. I can map this stream to object, take the index, return a new instance of what this factory can create, that is called the this.get method. Could put this here, right? And put the result in a list. And just return that. For loops are so Java 8. Java 7, sorry. Okay, so this is just one line to create this thing. And if I run this code, play with factories, 5 circles for each system dot out println, run the code, and get all my 5 circles created using this default method. Now, I have another constructor in my circle, which is a circle that takes a color as a parameter. So suppose I want to, what I would like to do now is to create, for instance, red circles. Red circles factory. Doesn't take anything. A new circle color red factory. This is the Java AWT color. Create, we could just copy paste this code. This is 5 red circle. Run this code, and in, oops, what did it do? Yeah, red circle factory get 5. Sorry, if I run this code, I have first 5 normal circles and then 5 red circles. So from a factory, I can add as many default methods as I need to create more stuff, to add functionalities to my factory, which is nice. What is not that nice is the way this code is written here. Because in fact, what I'm doing here is putting inside the supplier a parameter that I would like to pass as a parameter to another method. In fact, I'm not too happy with this code. I'd better write it like that. I'd prefer write it like that. Factory, and say, okay, I pass the constructor as a parameter, new circle of color, and then pass the color also as a parameter. Okay, this is what I would like to do. Factory, and pass it, for instance, to a factory method to the factory class itself. So this create method here is a static method of the factory class. we've been doing that. It returns a factory. Sorry. It returns a factory. It takes, what is this? It takes a color as a parameter and returns a colored circle. So this is a function. It takes an object, return an object of another type. Create. Takes a function. We are going to make it with a, this is a factory of circle, right? So we're going to write it like that. It will be easier. It takes a color as a parameter and a circle, my circle, and this is in fact my constructor, and takes a color as a parameter. And this should be, I'm going to return null here, and this should return, let me close those imports here, and this should return a factory that is something that doesn't take any argument and returns a factory of circle. So for that, I need to, in fact, take my constructor and apply the color to that function. Here, what I did is a very important operation. I took a function and made it a supplier by fixing the parameter of that function, right? And this is the second fundamental operation in functional programming. The first one is composition, and the second one is partial application. What I've done here is a partial application of a function to lower the number of parameters that function takes. Since this function takes only one parameter, lowering it will give me a supplier, and this is exactly what I did. So now my factory can be written like that. It's still working, by the way, okay, which is great. And since this is also a method reference, I can write it like that. And it gives me a very clean pattern, because if I compare the two patterns here, I've got this circle, column, new on both sides, even if it does not represent the same thing. This is some kind of a trap with method references, is that if you do not know the type of a method reference, you cannot really know what is this method reference exactly. You see, here I've got a method reference that is a supplier, and here this is the same method reference, the same string of characters for the method reference, but it's a function. It's not the same type, and it does not do the same thing, right? If I control-click on this new here, it will take me to the empty constructor of the circle, doesn't take any parameter, returns something. This is a supplier. And if I check this other method reference here, if I control-click on this new object here, or new call here, it takes me to the constructor that takes a parameter, because the type of this method reference is not the same. Okay? How do I know that it's not the same? Because this create method here takes a function and not a supplier. This is where the trick is. So be careful with those method references. Okay, I think we're done with the factory pattern. Yeah, the next pattern I would like to show you is the registry and the builder pattern. The registry pattern is a very nice pattern. Yeah, demo time, once again. Great. Demo time. So this time what I want to do is to create a registry, a factory that will create instances of objects with providing some kind of key to say, all right, what I want is a circle, what I want is a triangle, what I want is a square, or something like that. If I do this kind of thing, I'll probably end up writing this kind of code. Oops. Switch key. If my key is a circle, then I know what I want to do is to return. I'm returning a factory, right? New circle. If what I'm getting is a triangle, I want to return a factory of triangle. Yes, this one. And if I get a square, what I want to return is a square. It doesn't compile. What's wrong with it? This should be a shape. If I want on the default, let me write the default. And if I don't have anything, what I want to do is to throw a new illegal argument exception. Key is not known. And now I have this would be a factory of shape. My shape is this one. Okay. So this is something, and still have a compiler up, I guess. Okay. And I'm going to, which one is it? It's not this one. Yeah. So here I've got, so this is, I'm done with this one. So here I want to create my shape factory. Shape factory of shape. Shape factory equals new shape factory, right? And if I call shape factory, sorry, create circle, it returns yes, I've got trouble with the shape here. It's not the right shape. The shape I've created. Should have done that. Okay, so this is my circle factory. And I want to cast that into a factory of circle, since what I get is in fact a factory of shape. Right. It's not happy with it. Will it be okay like that? Yes. I've got this funny warning, so let us get rid of this with this kind of magic hack provided by the JDK, suppress warning unchecked. Yes, I know what I'm doing. Well, I hope I do. Okay, so this is basically the registry pattern as we all saw it in our application. Maybe not in this exact form, but basically this is what we can do. You see that this registry pattern can be created on the way we created the factory in the previous example, which is basically this one. By the way, if I want to create a singleton, for instance, I want to return always the same triangle. Here, if I'm with this factory, I am returning a new triangle every time I'm calling this factory. But if I want to make it a singleton, I could just create a triangle as a private. This is not static, so I can do it like that. Triangle equals new triangle. And with this trick, return always the same triangle with my supplier. This would be an implementation of the singleton pattern. As the singleton pattern might not be the best pattern of the world, but you can still implement it using this kind of lambda expression. What is not that great with this way of writing things is that what is not as great is that if I want to add stuff to my registry, I need to modify this code, recompile it, recompile all my application, and everywhere I need to use, I'm using this registry, rewrite my code everywhere. So this is not very, how could I say that, very dynamic way of handling registries. What most of the time people do to fix that is to use a builder pattern. Okay, I've got a builder here, which is a class. This builder pattern works in 2 steps. First step, I add elements to my registry. And then second step, I use my registry as it is by calling the build method and using this shape factory. We can just, yeah. I'm going to put this one here. So how can I use this builder pattern? I've got so many builders everywhere. Where is mine? It's here, all right? A builder, so it's a builder of what? It's a builder of shape. New builder. Okay, so in the first step, I'm going to add a circle and the factory of circle, which is circle new. And the same for triangle. Thank you, Eclipse. We'll deal with this error later. There's another triangle, and the same for the square. Just like that. And now that my builder is done, I just call the build stuff, the build method on it, to create my shape factory. And from that shape factory, I will be able to create my factories and use my factories as I need. This is, by the way, a pattern that has been used in the Stream API itself. If I check the Stream interface, I've got a builder, a member interface that extends consumer, in which I can add elements to it. I add elements to that builder. And once this is done, I just call the build method on that builder to create the stream with all the elements I have added to the builder. The problem is that once I have called the build method, I cannot call the add method anymore. So this object has to remember state. Okay, I am in the build mode, adding elements to my builder. And then I have created the object I was building, so I'm out of the build mode. And if somebody calls the add object again, I should raise an exception or something like that, throw an exception, to tell the people, hey, this builder is done, you cannot add any more elements to it. So if I come back to my pattern, I've got, in fact, the exact same problem in this pattern, is that once I have called this build method here, I need to create some kind of internal mechanism to make sure that nobody is going to add any more objects to this builder. And this may be quite complex. First, you need to write this code, which is not that simple. And second, you need to think that other people can access, using reflection, to your internal registry. Other threads could be doing the same also. So you need to handle all these kind of cases if you do not want to have any bugs in your application. This is not that great. Now, how can we make this pattern better? Precisely using lambdas. First, what we can see is that this shape factory here has only, in fact, one method to implement here. And when you have a class that has only one method to implement, you should have something in your mind telling you, oh, maybe I could make it an interface and implement that using a lambda. Because most of the time it's possible. I'm going to call this shape factory. I need to rename it legacy shape factory. And I'm going to create another shape factory. as an interface. And I'm just keeping the same method here. String key, where are you? Here. Like that. You can see that this code is still compiling, by the way. Yes, because it's now built on Shape Factory. No, please. Eclipse, please. What is he doing? He doesn't want to import the Shape Factory. Interesting. Okay, let us do it by hand. What did I do? Oh yes, it's not public, sorry. Yeah, all right. Should be working now. Okay. And this builder.build is going to return the shape factory. Yes. Okay, so my shape factory is now an interface, and I'm going to implement it using a lambda. Now, what is this add method going to do? Well, it will have to put this in some kind of registry. So let us create that map. This is the natural way of doing it. It's a map of string and factory of T, registry, new hash map. Okay, and what I'm going to do is just add this registry, put yes key, and value, the value is the factory. Okay. And now, when I'm building this stuff, what I need to return is a shape factory. What is this shape factory? It's an interface that is functional, so it can be implemented using a lambda. How can I implement it using a lambda? Just copy-paste the block of parameter. So it's not this one. It's in my builder. And from that key, I need to get the factory that is here, because this implementation returns a factory, and the factory is in the map. So do this kind of thing, registry.get key. Sorry. I'm still having troubles with the generic stuff. Where am I? Excuse me? Make it what? Oh no. I'm going to make it private, but final is on the factory. Why do I have a shape here? Yeah. Okay. So in fact, this build method is just, I'm going to make it like that, you see. I'm going to copy paste this code, copy it here, because in fact this code is a method reference. It's just the get method of my registry. And this is what it is. In fact, the builder is just a registry. And when I create the stuff, I'm just giving access to this map. But I'm still not quite happy with the code, because here I have some code that is going to call add multiple times, and to code that can be interrupted, that can be made multi-threaded, that is subject to reflection. It's not that great. But if I check what does this code do, in fact. And I'm going to use the same trick I used to show you how the comparator was made. If I extract this code to a method, what I see is that, in fact, it's a piece of code that takes a builder as a parameter and does not return anything. So, in a sense, what is this piece of code? Takes something, does not return anything. It's itself a lambda expression that is a consumer, right? So, in fact, all this code can be returned as a consumer. Let us do that. It's a consumer of what? A consumer of builder, okay? Consumer of builder of shape. Let us call it consumer for the moment. It takes a builder as a parameter. I'm just going to write it builder like that. And does this here. I can get rid of this method. Do not need it anymore. And now, the nice stuff is, I do not need that builder anymore. I do not need a builder in my application code to initialize a builder. I have created a model of initialization, and this is a very, very general pattern. In fact, the process of initializing an object using a builder is basically a consumer. So you can write this consumer, pass this consumer, this extracted stuff, I do not need it anymore, pass this consumer to a factory method of our builder interface, builder create, pass this consumer as a parameter, and now what I expect to have as a returned object of that method is a builder object that is both created and initialized with the consumer I have provided. Okay? So what is this method? Obviously, it's a static method on my builder interface. Public static. What did I call it? Create. Takes a consumer as a parameter, returns a builder. Okay, builder of T. I need to tell that this is a T. Create, and takes a consumer of builder of T as a parameter. And this is my initializer. Let us return null to see if we got it right. I think so. All right. So now in this static method, all I had to have is create this builder. New builder. Okay. And pass this builder as a parameter to the initializer we just passed, like that, and return this builder. Okay? So you see that now I'm in a better shape than previously because I cannot interrupt the process between the construction of the object and its initialization. It's not possible to interrupt it anymore. But I can go even further because now I'm just calling this create factory method. So this build method here is not used anymore. I can just get rid of it. Okay? And what I see here is that I have only one method in my builder object. Well, if I have only one method, it probably means that one instance method. If I have only one method in my builder object, it probably means that I can make it an interface and make this method abstract. Let us do that. I'm going to comment out this code, make this method abstract, and make my builder an interface. Now, of course, this registry here cannot be an instance field of an interface. I cannot create this builder like that anymore because it's not an object. But this is a lambda, so I can implement it just using an implementation of this abstract method here. So let us do that. I just copy-paste, always the same principle. I just copy-paste the block of parameter. And what should I be doing with that? Doing registry.put key and factory. This registry cannot be created as a field, but it can be created as a local variable. All right? So first, I create my registry. Then I create my builder. Third step, I initialize my builder using a consumer, and then I return it. And this piece of code here is in fact a method reference. I'm going to keep that. So if I really want to make my code completely unreadable, I can just write it like that. Okay? Yeah, well, I still need to return the stuff. Okay? Sorry. Okay? So you see that using this kind of code, I can go really very further with only very simple principles. That is, try to get to understand where the lambdas are. When I have a class with only one method, have in mind that I can implement that class. Well, I can make an interface with that class and implement it with a lambda. And you see that here I'm in a very better shape, much better shape than I used to be in the previous example. Okay, this code doesn't work anymore. The build method is gone. Okay, in the first step I had the creation of an object in a class. The registry was a field of that class, remember? Here. This was a field of that class. Anybody could have access using reflection to the field of that class, meaning that I could correct my code with reflection or concurrency or things like that. Now my registry is completely hidden. It's a local variable in a static interface, so nobody can see it even using reflection. I do not have to use a concurrent hash map here because this code will be executed just by one single thread. You can have a local variable shared among threads. This is not possible. So this code is both much more robust and much less error prone than the previous one. It might not be that simple to write, I agree, but it's still very, very interesting code to write. And I think I'm done with it. Yeah. All right. So this is my conclusions. My conclusion. You see that lambda expressions have been presented as a nicer way to write instances of anonymous classes, and default methods have been presented also as a way to modify existing interfaces without changing classes. This was useful to know when Java 8 was new. This is not the case anymore. Java 9 is there, by the way. And in several years from now, nobody will remember what it was before Java 8. What will stay, I think, is that we have a new model of function in Java, which is called the functional interface, with two possibilities: composition, given by default method, partial applications, which is the second fundamental operation in functional programming, and also factory methods to create easily lambda expression using parameters. So this is really a new way of creating applications and implementing patterns, and I think it's a very nice addition to our applications and APIs. This is what I wanted to tell you today. Thank you for your attention. And I think we have some time for questions. Do we? Yeah? About 15 minutes? Questions, you know? Yeah? Yeah. If you just Google my account on SlideShare, you'll find it. Yeah. Yes, I can post the code in my GitHub account. Okay, I'll do that. I'll do maybe do some cleaning before that. Any other questions? Yes, please. Sorry? You have to specify the type, yes. No, it's optional. When you write your Lambda expression, it's really a matter of readability. If you think that your code is more readable by specifying the code, if it helps you, just do it. There's no difference in the way the code is compiled and the performance of the code executed. So it's just a matter. It's the same for Lambdas versus method references. If you're more comfortable with Lambda, just keep your Lambda in your code, and as time goes by, you'll probably become used to method reference and like to write your code using that. But the compiled code is the same, so there's no difference in performance between method reference and Lambdas. Questions? Yeah? There's an excellent book written by Maurice Naftalin about Lambdas and stream. I do not know of any book especially on Lambdas, only on Lambdas. They usually cover Lambdas, the new methods on the collection framework, streams, and collectors. And I think the one written by Maurice Naftalin is excellent. It's available in the library. And there's also Java 8 in Action by Richard Warburton and Gabriel Irma, which is a very good book too. You've got others. In fact, there are 4 or 5 books available. Yeah. Yeah.
If we were given the exact class name we wanted to build, would you get rid of the switch statement in the folder?
You cannot switch on a class name. The switch only takes primitive integers, enumerations, and strings. You cannot provide a class in a switch statement. So you have to provide a key, which may be the class name or any kind of label that would represent the class. There are other ways to implement this pattern. You can also implement it using enumeration, for instance. First, get the enumerated value that you need, and then call an instance method on that enumerated value that will give you the right factory. It's not the only way to do it, but this one, the one I showed, I think is the most classical way of implementing it. Yeah? Yeah? Yeah. I'm not sure I quite get your question, sorry. Yeah? Yeah. Ah. Yeah. Usually, when you're using a dependency injection framework, you can also provide factory methods to create your objects, whether it's in Spring or in CDI, for instance. So just by annotating the right pieces of code around. So you can still do that, and yes, leverage Lambdas for that. But the dependency injection framework will create proxies on objects. So if you're using Lambdas in them, your Lambdas will be kind of cluttered with all those proxies, and you will lose most of the good things you will have when using just plain Lambdas. Basically, a Lambdas is not implemented as an object inside the JVM, but if you're calling the toStrings or equals or the object methods on a Lambda, which is still possible because it will compile, then you are losing all the optimization the JVM will be able to set up for you when you're just using plain Lambdas. So if you're using plain Lambdas, just use them as is. Do not do any funny stuff with them. Yeah. Yeah?
Can you change performance-wise the Lambdas from Java 8 to Java 9?
I did not heard of any. I don't think it has. I can't be exactly sure of that. There is room for improvement. The way lambdas have been implemented in the JVM, there is room for improvement in the future. I'm not sure there were major modifications on that field in Java 9. Any other questions? Okay, thank you for your attention. Have a great day.